Good afternoon or good morning, everyone, and thanks for joining today. I'm David Tasker from Chapter 1 Advisors, and I'll be hosting today's session. Today's webinar is focused on Adisyn's graphene-based technologies, including the company's radar absorption initiative targeting UAV and defence applications. We'll also hear briefly on the semiconductor side of the business, which remains a core focus of the company and is advancing at a rapid rate. We'll keep things fairly tight. Presentations will run for about 20 minutes, followed by Q&A. If you have a question, please submit it or them via the Q&A box on your screen, and we'll get to as many as we can. Joining us today is Adisyn Managing Director, Arye Kohavi, who will take us through the radar absorption initiative, the progress to date, and the commercial opportunity. We're also pleased to have Non-Executive Chairman Kevin Crofton joining us. Kevin will provide a brief update on the semiconductor work being undertaken, which remains, as I said, a key part of the broader strategy. Kevin, Arye, over to you.
Thanks a lot. Good morning.
Thank you, David. Good morning. And good morning, everybody. David, are you going to drive the presentation?
Yes, just advise us to move through and we'll fly through the slides.
Right. So first of all, let me say thanks to everybody who decided to join this webinar. It's nice to have you here, and it's nice to be in front of you, albeit it's only in 2D. Okay, thanks for the technology. We're able to have a quick chat today. Look, my objective really is twofold. Of course, I want to be able to be part of Arye's presentation regarding this new opportunity, this new, very exciting application of graphene to the UAV sector. It's really an opportunistic situation for us. But also, the second thing is I really want to make sure that I stress, as David just did, the company remains absolutely focused on delivering the graphene interconnect solution to the semiconductor industry. And Arye and the technical team and myself, we have a regular technical review of what's going on with that program. Of course, it's not a work of a moment, as you all know, but I can assure you that that program is going on schedule. We actually expect to have some very good results to be able to shout from the mountaintop about very soon. I'm certain that we are well on the way to deliver graphene that is actually going to be able to be applied and used as an interconnect material in the broader semiconductor industry. As a result of where we are and the announcements that we've had and the work that we've seen going on, we've had discussions with some of the largest companies in the industry already. They are watching what we're doing. They are absolutely focused on what we're doing, and they see this as an opportunity to actually solve probably the biggest challenge that the industry faces, and that is, can we continue to shrink the die, increase the number of transistors that we deliver on each chip that's functioning on each chip, and really move the whole industry forward. So companies like Intel and TSMC, to name a few, are very well aware of where we are. And some of the largest capital equipment companies that would be the people that deliver this process on their equipment are also fully engaged. So it's really just a matter of time in this case. We have to get our recipe to the point where it is repeatable and that it is reproducible on scale, starting off with a 1x1 coupon of material. But after that, it should be a very rapid expansion. And that's the next milestone we're looking for. Graphene on a 1x1 centimeter coupon that is functional. And we're well on track for that. And I'm excited where the team is at the moment. The program that we're going to talk to you today does not detract in any way from the core mission of Adisyn. It's a modest investment of funds to get this across the line. It's a rapid program, and it's something I think you're going to find very, very interesting. But the core industry activity in a semi space is on track. So those are my opening comments. I suspect that all of you are aware that the semiconductor industry continues to accelerate. When I first talked to you a year and a bit ago, I was telling you it was going to be a $1 trillion industry by 2030. Most of that has moved forward. Most companies now are saying it's going to be over 1.2 trillion by 2030, which implies, of course, that we'll cross the 1 trillion sector size business sometime in the next 2 years or so. And the bulk of that growth from 600 billion to 1.2 trillion is mostly coming on the backs of very, very high-end applications, which require the ability to conduct electrons. And that means we need to have graphene installed. So we're on track. Companies focused on that. But because of the core competence of Arye's team, we have an opportunity here, and I think it's important that you hear about it as well. So those are my comments to open up. I'll take questions later on. And Arye, I'm going to hand this over to you, please.
Thanks, Kevin. And we have an exciting week on the semiconductor, we can just say. David, continue with the slides. Here. The story begins 5 years ago. And when I founded the company, because I read an article that graphene or graphene materials, graphene combined with other materials, can make a thing invisible to radar. I read an article in the newspaper. I was after my previous company, Watergen, and I thought that it might be very interesting to me. I team with, and I look for who can fulfill my dreams. Team with Bar-Ilan University, with Professor Doron Nove over there, which is a world expert in graphene. And we founded the company to do that, to do graphene for radar observing. And we even did several experiments over there. We're speaking about 2020, beginning of the COVID. And then he got a call from Intel. Intel, as you might know, has a huge presence in Israel. And he got a call saying, we have a problem with interconnect. We tried to invest $100 million to achieve graphene for interconnect, and we failed. And we contact you because maybe you have an idea about how to bring graphene to the semiconductor. And then we had an idea of how to do it by ALD. And because of this call, we convinced to move to semiconductor and to leave the radar aside. This is 2020. Half a year ago, I read in the newspaper that hundreds of drones are being hit in the air in Ukraine-Russia battle. And I thought to myself, I have the old dream. Everything right now is on track. Let's try to find out if it works first, and then to realize I succeed to convince Kevin and the board to let me just have an initial test. We decided to find out if it works first and if there is any demand for this application without announcing it to the market. And I looked for an expert in the field of radar. I was introduced to Professor Pavel Ginsburg from Tel Aviv University, that everybody said Pavel is the knowledge center of radar in Israel. So I told him, let's try to find out if it's correct, if graphene materials can make things invisible or absorb radars. And he said, yes, I know, I read some articles, let's try it together. We team means we sign agreement with Tel Aviv University. It's called research and option. When we have option to take this activity to our ownership if it works. So we sign a research and option agreement with Tel Aviv University, and we start the experiment. We brought him materials. I will call them graphene. It's not really graphene. It's graphene combined with other material with certain specification. It's part of the secret and the IP, but I'll call it graphene here. We gave him graphene. He put it. We put it together inside the materials, and we check in the radar. We were amazed. We sought to have results of. I'll explain later what does it mean of 10 to 15 decibels, and we reached 20 decibels. He said, we never saw something like that, he said to me. And then we said, okay, let's find out if the market wants that. So I asked, I have a friend that is very, very high rank in the army. He was running the Arrow and now an Iron Dome and all those fields. And I told him, have some calls and find out if it's needed. And he came back to me and said, you will not believe, everybody wants that, everybody wants to speak about that. So we decided about 2-3 weeks after we had the results to update you and to tell you, okay, we're examining it seriously. And when it's progress a bit more, we decided to have a subsidiary that focused just on that. And here we are. We thought that it's the right timing to tell you the story, to explain the opportunity and what it takes, because you're our partner and we want you to be involved and know what's going on. So the topic of what we're dealing is that right now drones has a lot of advantages. I can tell you secretly that more than half of what Israel and US is doing in Iran is done by drone and not with airplanes. More than half of the activity, for sure intelligence, but all the rest of activities is done by drone. But drones right now are made from carbon-based material. Carbon-based material are excellent for aviation. They are light, they are strong, but they are completely fail against radar. And now I should explain you something about radar or this field. Any object in the world has its original size, and there is the size of the radar signature. It's not the same. It depends on the material, it depends on the movement, it depends on a lot of things, but there is the real size and the radar signature. How big does it seem on the screen? Drones, in general, are seen much bigger than their original size. Why is that? Because most of them has propellers, and propellers make huge radar signature. It means that a drone of 1 by 1 meter size looks on the radar like a F-15, much bigger than its original size. It's because of the materials, carbon-based materials, and because of the propellers, and because of Doppler effect and things like that, and several other things. So drones right now are, most of them doesn't do their job. They've been hit in the air. In Ukraine, Russia, 95% of the drones are being hit in the air before fulfilling the mission. And we're speaking about all the range of drones from the small ones, 1 meter, until things that look like airplane with no pilot, all this range of drones. So this is the challenge. This is where we're dealing, and this is the problem. Next slide, please. So let's speak about the decibel and what does it mean. Decibel is a logarithmic curve, meaning that, for example, here there is 30 decibel. This is our target. 30 decibel means that any object will be 1,000 smaller than its original size. This is the meaning of 30 decibels, reduced by 1,000 times. It means that a standard drone, which is typically 1 by 1 meter, if you reduce it by 1,000 times, you're getting an object at the size of 10 square centimeter. 10 square centimeter means 3.5 centimeters by 3.5 centimeter, meaning a butterfly. So the object that right now looks even bigger than its size, it looks like F-15. If we succeed to reach 30 decibel, we'll look like a butterfly. What does it mean? It means invisible, because radar cannot detect all the objects in the air. Otherwise, all the radar screen will be full of targets. It cannot detect any bird, any butterfly, any flying object, anything in the air. So radars are forced to ignore little things. So if you succeed to do 30 decibels, it means that any object will be invisible to radar. The radar will not detect it. It can arrive its mission without any problem. This is the truth. Next slide. So again, before we decided to announce it and tell you the story, we had the first experiment. We took material, plastic material. We added our materials to that, the graphene, kind of graphene. And we, at the first shot, we succeed to reduce the radar signature by 20 decibel. 20 decibel means 1 to 100. So the 1 by 1 meter became 10 by 10 centimeter. When I spoke with the industry, most of the industry said, oh, 1 to 100 to 1, it's maybe enough for us. But we still put a target of 30 decibels, I mean 1,000 to 1. But we already got results of reducing the radar signature by 20 decibels, mean 100 to 1. This is it. Next slide, please. So we have proven a 20 decibel reduction. Over there on the left, you see how the radar lab of the professor looks like. It's a lab that covered with all those weird things. And it's big enough even to flying drones inside and measure that at actual behavior. So we succeed to reduce the radar signature by 20 decibel, 1 to 100. And we decided that we want to have a target of 30 decibel, 1,000 to 1, before the end of this year for a flying drone. This is the target we put to ourselves. Before the end of the year, 30 decibel with a flying drone, not just an object. So this is our race. We believe we are able to do it because the reduction of 20 decibel was without a lot of things that we want to do. I would say, in confidentiality, that we believe that not all the material should be in the same concentration of the material. We might have several materials inside. We have a lot of things that we're going to do in the R&D in the next few months. But because we succeed to have a 20 decibel measured result, we believe we are able to do it. And again, the industry said to me, 20 is amazing. We can progress with that. So this is our target for this year. It's going to take 6 months, 9 months to have a flying drone. In the way we'll have several results that probably we'll be able to announce about the achievement of reduction on the ground, achievement of reduction or submitting a lot of patents around this technology. This is part of what we are going to do in the next few months, and teaming with the industry to build the objects that they want us to build and measure. Next slide, please. Industry demand. As I told you, I asked my friend, the general, to have several calls and understand if it's needed and what is the purpose for that. He had about 10 calls with the seniors in the industry, the defense industry, with the military, with the Ministry of Defense, with there are several drones companies in Israel. Some of them are traded on the Nasdaq at billions of dollars. So we had several calls and called me after any call and said, you will not believe. Everybody I spoke with said, yes, it's very, very needed. No, we haven't heard about any other solution. Right now, we are dealing with an active protection. Active protection means some kind of systems that send waves to disturb the radar. It's another machine. We never heard about any activity that deals with the radar signature on drones through materials, for sure not 2D materials. And his next sentence was, everybody wants to meet us. So my calendar right now is full of meetings with the Ministry of Defense, several departments over there, with the industry, with drones company, with a lot of people in the industry, because the bottom line is we need that. Come to a meeting. So this is the clearest industry demand I ever saw. I must say, in general, we try to test it to find out if there is opportunity over here, and we realize we step into a gold mine. Everybody wants that. We have amazing results already. We build the team. I'll speak about the team in a few minutes, and it seems amazing. Next slide, please. Size of the prize. At the beginning, we thought, or we were focusing on just the propellers, because as I told you, the propellers are a big part of the radar signature because it's movement and all this. We sought to focus on propellers, and the initial experiments we did was done just in Tel Aviv University, and we saw that there is, I will say, they are not very professional in molding and in plastic. They are very professional in radar, but not in molding and plastic. And I told the university, you're not going to do the molding. We want to team with world leader in molding, companies that do it a lot, have all the know-how of how to do it right, in meaning of which technology of molding, maybe 3D printing, or the knowledge of how to have different concentration inside, or all those things. And we found a subcontractor like that. When we'll sign an agreement with him, we will announce it, with presence all around the world. And they're doing millions of components every year. And the important thing to say is, because we have this kind of subcontractor, now we enlarge the fields that we are going to deal with, from just propellers to the body of the object themselves. For example, here you see all the, I'll still call them airplane, all the body of the drone is built right now with a carbon-based material, as I said earlier. And carbon-based material are expensive. They're not really in mass production because they are very spoiled. And when we started, we thought to deal just with the propeller. And now, because of the subcontractor, we offer the industry and the Ministry of Defense to deal with all the body of the drones. Drones, drones right now, I told you it's half of the activity in Iran. Everybody thinks that it's going to be, within 10 years, maybe it will be 100% of the activity, and pilots will be something from the past. It's a huge market. It's unbelievably huge market, growing market, everything you can dream about. And I'll say one more thing about this market. It has all the range from special units in Israel or in US Army. Special units will pay, money is not an issue over there. If they want some capability, they're gonna have it. And this is why the first meeting, or the first organization approached us last week, was the very, very special unit in Israel. They operate a lot of drones for a lot of things. And he called me and said, I don't care about money. I need this as fast as possible. But special units is one thing. The main thing is those ones. The tens of thousands of drones doing a lot of missions, intelligence, bombing, all this. I might have an alarm within a few minutes, so this is the prize. Next slide, please. We team with Tel Aviv University, as I told you. This is Professor Pavel Ginsburg, very, very world expert, leading Israeli Special Forces. We're a very good team right now. So the team right now is the molding company, the plastic molding company, the university, and us. Our part is the material and to manage everything, and of course the market approach. I want to say something clear. It is not disturbing our activity. We're doing the semiconductor. We had an amazing result this week. You will hear about that when it will be finished. I have just part job researcher helping me with the radar operation, and all the rest is done. We hired a student from Tel Aviv University, Professor Pavel, the molding company. All this is operated by us, but is not disturbing at all our main activity. Next slide, please. Where we are, and I know that there are a lot of brokers in this meeting, so I'm answering the next question of what is the news flow? What is the news flow? So this is the news flow. We already done the proof of concept of 20 decibel. we founded a subsidiary called the 2D Radar Observers. We are in discussion with the Ministry of Defense for grant application. I'm going to have a meeting this Thursday with the main grant operation over there, next week with the Special Forces grant application. I believe we're going to have grants that will cover all the expenses. So this is an answer about the budget. I don't think that we need to invest significantly here. We put a budget of, in our board, we put a budget of 100K Australian dollar. I think is the maximum we're going to spend this year, because we're going to have grants and maybe even purchases from the industry. So this is where we are, and it's neglectable in our budget. We're going to have manufacturer collaboration. The subcontractor, I told you, we'll announce it when it will be signed. We're going to have a defense-focused advisory board. I believe in anything we're doing, we should have the best people on board and decide together where to go. Probably people from the industry, from the drones industry, in Israel, maybe in the US, maybe from Australia. We're going to have a very strong defense-focused advisory board. And we start the drone company collaboration. I have a meeting next week with the biggest one in Israel. I must go for alarm. I'll finish that. Kevin, please answer the questions. We have alarm here in Israel right now, so apologies.
Okay, Arye, good luck.
So this is it.
Great. So, sorry about that. I didn't, of course, nobody anticipates you'll have an alarm in the middle of a presentation, but I guess the Israeli teams are being summoned to the bunkers at the moment. So I'll try and carry the ball for the rest of this activity. So I think it's pretty clear what Arye had presented. I hope it is. It's a really interesting application of graphene plus other materials to create a coating, or in some cases an additive to an existing material to reduce the radar cross section. That's a very interesting trend and opportunity for us to execute on. We already said you once before, I want to reinforce that the semiconductor interconnect program is absolutely on track technically. It's accomplishing what we've expected and what we plan to do. And I'm convinced we'll be in commercial or joint development program relationships, collaborations with some of the companies we've already mentioned, and there'll be some others that will also be involved during the course of this year. So I'm quite excited about where that stands, and we have a chance to actually change the industry. We already talked about how the RCS program will go, the radar cross section reduction program. Currently, you follow the company. We're trading around penny a day, 49 cents plus or minus. So market cap sits at about 40 million. And we're in good shape with cash. We have minimal cash drain coming from this RCS program. So I'm quite convinced that we're keeping this contained so that it's a focused opportunity that allows the broader team to continue to concentrate on the semiconductor space. So David, I'll ask you to go to the next slide if there is one. I don't think there's anything we really need to say here. You all know Arye and you know myself at this point. At least I hope you do. Next slide, please. I think that should be the end of this activity, David.
Thanks, Kevin, and Arye, who will come back if he is able to. Clearly, a lot there across both the defence and semiconductor opportunities. We do have a few questions that have come through, so we'll jump through to them as quickly as we can. One question that I think you have touched on is focus. is there a defocus here, or is focus still able to be given cleanly to semiconductors as well as the drone radar technology, both from a financial and a people point of view?
Yeah, so let me take the people part first, and then I'll talk about the financial part. So from a people perspective, as Arye just mentioned, it's himself plus a half of an internal researcher plus a research student, I'm going to say, from Tel Aviv University to contribute to this program. That's what we're sponsoring. It's an absolutely minimal, in fact, negligible contribution to our cost line at this point. In the future, on people as well as costs. So more than 95% of our team are dead focused on the semiconductor space, and they'll remain so. In the future, as Arye mentioned, we are going to be applying for grants, and they're not going to be trivial. And assuming those grants get approved, then there'll be a cash flow into the company, as well as the potential that we would start to scale that to a small degree. In addition to that, though, David, we're going to be relying on relationships with contract manufacturers. Arye already mentioned the use of potentially a plastic molding company to deliver this technology. So the amount of resources that would be required from Adisyn is small in terms of people. It could grow, but it's only going to grow from a financial perspective, assuming the money is there and it's fully funded with margin. So that's how we'll approach that activity. Hopefully that addresses that question.
It does. Does the application of graphene hinder the drone's flight path or performance?
No, it doesn't at all. So relative to flight path performance, at least as far as we know now, the answer would be no. Oftentimes we get a question about, is there an impact on weight and balance? At this point, we can say we don't think so. Any weight gain, which would often have to have an impact on center of gravity, for example, and control surface effectiveness, all of that looks like it's going to be a non-issue, and any nominal change would be far offset by the reduction in the radar cross section. So at this point, we can say no, we don't see that as an issue. We know that we can produce the control surfaces and the body surfaces, and we believe the propeller as well. We believe we can dimensionally control all of that with proper rigidity, with proper structural capability, so that it looks like a standard drone. So I think right now we can say no, it's a non-issue.
And what about the patent position as this technology advances?
Right. So Arye mentioned that this is a relationship with Tel Aviv University. They have some core patents in this space that they've applied for, as does Adisyn. So the option that Arye mentioned that we need to go negotiate with TAU is that all of those patents and all of those patents that have been provided for will actually come into the purview of 2D radar absorbers. So it will ultimately be our patent portfolio. Some of it is coming directly across from Tel Aviv University. Some of it is actually core to Adisyn itself.
And what might seem as a bit of a fundamental question, where does the graphene come from for both of these projects?
That's a great question. Nobody's asked us that. Actually, the source material comes from, so let me say it this way, nominally, the precursors are delivered from specialist chemical companies and material designers, material as in construction material, that are looking at bespoke molecules on the semiconductor side on our behalf. The actual molecules themselves are being identified by our researchers. So it's an outsourced activity to get the precursor material necessary to do the ALD process. Similarly, the graphene and graphene alloys that are coming for this radar cross-section application, there are multiple sources around the world for the source materials that we need to be able to develop the powders for this application.
And there's a couple of questions here, so I might try and group them. Who ends up being the ultimate customer for this type of technology? And will the technology need to be embedded in the components as the components are being assembled or after the drone has been manufactured?
Yeah, that's an interesting question. It's, in some respects, David, I'll take the cop out and say it's a little bit of all of the above. So, for example, during the manufacturing process, you can imagine that we could be introducing layered materials with different levels of this graphene-based alloy that's actually as part of the composite material that we're using to make these bodies. On the other hand, you can also see it as being a powdered coating for certain materials or certain surfaces that could also suppress the radar signal. So it really depends upon where you see the hot source, quote unquote, for the cross section itself, and how do we manage that. In some cases, it'll be injectable molding bodies with this material added to that plastic, as an example. In other cases, it could be powder coated carbon surfaces as a possibility. Right now, we're working on propellers, because that is the largest source of the radar cross section problem. In that case, it is actually the material is embedded inside the base body itself.
Arye, great to have you back.
He's back.
I think so. But I might just ask, across both verticals, what are the key milestones investors should be watching over the next 6 to 12 months?
Well, I think so. We'll do the radar cross section one first. So, as I already mentioned, what you're going to see is we expect anyway to have a relationship with the Ministry of Defense in Israel. Perhaps there'll be other relationships as well. You can use the MOD as a potential insertion into the U.S. Armed Forces. So we expect that we'll start some contractual relationships there. We do expect that we'll see a relationship, one or more relationships with a contract manufacturing relationship to actually produce these bodies, if you will, at least in the minimum of a prototyping application. So that should happen during the course of this next 9 months. And then I would hope and expect, I mean, we already know we can get a 20 dB reduction, at least in lab experiments. We'd like to push that envelope to a 30 dB reduction, as Arye mentioned. And I expect, so from a technical milestone perspective, you'll see that during the course of 2026. On the semiconductor industry side, I already mentioned, we expect to be able to show, as I've said multiple times in multiple meetings, the ability to put this material, graphene, pure graphene, down at a low temperature being below 500 degrees Celsius, because that makes it suitable for the semiconductor industry fabs, the people that make these chips. We expect that we'll be able to do a 1 centimeter by 1 centimeter coupon surface coated with this material. It won't be perfect. It'll have some defectivity. The industry absolutely understands that. But as long as we can say we've done a 1 by 1 centimeter coupon, and that we can do that repeatedly, and that we know for sure that it's graphene that we're actually putting down, that's the technical milestone that we are extremely close to, and I expect we'll fulfill that in the next next few months or less. At that point, then
I will add to that.
do expect. Sorry. I do expect that we will see and we will have developed relationships with probably a capital equipment company and quite possibly one of the large device manufacturers as well. But that'll be to come, David, once we get to that technical milestone. But I do expect that to be this year.
And just before we close, if investors take one thing away from today, what should it be?
Well, for me, it's quite clear. I mean, the company, Arye's team, Adisyn in general has a competence in graphene and graphene applications. We've always said that there could be alternative applications that we could potentially engage on. Our main focus is on this semiconductor space. That's the prize that we are going after. But we will opportunistically take advantage of situations as they arise. I would say that the investment premise here is quite strong. It's a real opportunity to solve some of the industries on the semiconductor space. It's the biggest problem that we're dealing with, and of course the highly topical drone potential impact. So for me, it's a definite pull and a definite opportunity to be wildly successful.
On that note, Kevin, we have exhausted all our questions and pretty much exhausted our time. So thank you for your presentation and also for jumping in and answering the remaining questions. Obviously, thanks to Arye for his presentation and insights, particularly into the drone technology. So thank you to you both.
Thank you.
And thanks everyone for joining today. If you do have any follow-up questions, feel free to reach out. The company would be more than happy to answer any. We'll keep you up to date and the market updated as the story progresses across both verticals the company is advancing. And as you've heard, there's a lot of news to come. So we'll be sure to keep you all updated. So have a great